So this is lesson 5, stretches of periodic functions. I'm just going to go through vertical stretches first, and then the part 2 of the video will be horizontal stretches, and then we'll do some examples. So just to remind you of what sine and cos look like, for the sine graph, one cycle is like this, and we have our 5 key points, 0, 0, 91, 180, 0, 270, negative 1, and 360, 0. For our cos function, it's the same scale, but we start at 0 and 1, then we go through 90 and 0, 180, negative 1, 270, 0, and 361. Okay, so we could ask you to do stretches of sine or of cos, and this is the base graph that you start with. So you always start with your 5 key points for sine or for cos. Alright, for stretches of periodic functions, for the vertical stretches, the equation looks like this, where trig could be sine or cos, depending on what the question is asking you. And a is the number in front of sine. So, for example, if we ask you to sketch one cycle of the graph, okay, I'm looking at my equation, this is my a value. So this means I'm multiplying all my y values by 3, right, if we're using mapping notation. So if I take my key points, I'm multiplying all my y values by 3. Okay, and you'll notice I'm using the sine function because in the question it's saying sine, not cos. Okay, so if we use mapping notation, what we would do is we would take all of these values and multiply them by 3. Okay, you'll notice that if I take my 0 points and multiply them by 3, they don't change. So my points with 0 in them actually stay the same. The only points that are affected are 90 and 1 and 270 and negative 1. So if I multiply 1 by 3, I have 90 and 3. And if I have 270 negative 1, now I have 270 and negative 3. Okay, so what that would look like if I sketched it, my 3 0 points would stay where they are, but what would change is my other 2 points. So normally for my base function, that's where my points would start, but I'm multiplying them by 3. So instead of being at 1, now my maximum is at 3, and my minimum is at negative 3. Okay, so when I sketch my graph, my amplitude has changed from 1 to 3. Okay, so when we state the amplitude and the period, our period has stayed the same. It starts at 0 and it ends at 360. So our period is 360 degrees. But our amplitude has changed from 1, where it normally is, now up to 3. Okay, so the height of my wave has changed to 3. And if we're going to state the domain and range for one cycle, that would mean our domain is between 0 degrees and 360, and our range is between negative 3 and 3. Okay, so remember our domain is always from the start to the end of, because it says for one cycle, we limit it between 0 and 360, and our range is from the maximum to the minimum, so from 3 to negative 3. Okay, so vertical stretches. Okay, we just want to talk a bit about what's affected by the vertical stretches. So you'll notice that the amplitude was affected. Okay, so what the vertical stretch does is it affects the maximum and the minimum values, and because the max and min are different, the amplitude changes. Okay, you'll also maybe notice on the last slide that the amplitude is equal to the numerical part of the vertical stretch factor. Okay, so we had 3 sine x in the last example, and our amplitude was 3. So this number here, the a value, matches up with the amplitude. The last sentence here, the sign of the vertical stretch is ignored because the amplitude is always a positive value. So if, for example, it says negative 3 sine x, our amplitude would still be just 3. Okay, so we don't include the negative sign when we're talking about amplitude. So just to summarize, okay, the same as for all other graphs we've done this year. When a is greater than 1, so when a is a positive number, the graph is expanded vertically. When a is between 0 and 1, so 0.5 or 1/2, the graph is compressed vertically. And when we graph it, what we want to do is we want to multiply the y values by a. Okay, and what we can tell without even having to graph it is that the amplitude equals our a value. So it's kind of a quick way to find the amplitude if you have the equation. Okay, so a couple of examples. Well, we could give you the equation and ask you to state the amplitude. So the amplitude for this one would be 2. Okay, the amplitude for the second equation here would be 1/4. And the amplitude for the last one would be 4. So we don't take into consideration the sign because our amplitude is the height of the wave, which is always positive.